Okay, yes, hi everyone. As my handy assistant has said, I'm Elyse, and I'll be talking today about the Natural Language Toolkit, which is acronymed as NLTK. Looking at my lovely intro slide, you might notice two interesting things, the second of which is that I've amended my subtitle with the word "and failing." This is just basically an ask covering exercise. I was looking over my slides last night and I thought, I'm actually showing quite a few examples of how things can not work when you're using the Natural Language Toolkit. But I think that's good because what I've gathered from doing a bit of reading here and there is that a lot of the time when people are using this, they generally need to know why things are not working as well as why things are working. And of course, the first thing is the title, which is obviously just me being a bit smart. Because, I mean, as much as we'd like everyone to believe that we programmed before we could communicate with other humans, it's just not true, unless maybe we were building Turing machines with our blocks or something. But I think it's an interesting point. So I'll start with the question, why might human language manipulation be difficult for the average tech person? And so, programmers, they tend to be, I think, drawn to logic and concrete situations over feelings and abstractions. So you like 0 or 1 rather than like the word maybe. But I like the word maybe because it scares scientists. And so following on from this, we like to produce things rather than producing ideas. So we really like to write the code, but nobody really wants to do the documentation. Historically, male-dominated field. So, you know, obviously we all like the same things, boys and girls, but I think in my interactions with all the guys that I know who are programmers, I think there's a little bit of a difference in how we see things and the perspective we bring. So basically, girls are awesome, yeah. And so I think most importantly, there's a real disincentive to learn to be creative with human language if you're a programmer. I do a bit of creative writing and I find that if I spent too much time in that mindset, it's sometimes a little bit hard to get into the programming or technical writing mindset. So some people can switch really easily, and obviously there's creativity in programming, but it can be slightly different, and so there's that challenge. So the Natural Language Toolkit, as you would expect from a toolkit, it brings together a whole bunch of different tools and resources that enable you to play around with language. And so in this way, it kind of bridges this gap between science and art. But as with everything in life, you only get what you give. So you need to know what to ask it to do. It's going to be fairly inaccessible to anyone who doesn't know how language is put together on the basic high school stage. And even if you're someone like me who is pretty good with language in general, but is not, a linguist, sometimes it's just utterly baffling. So I'm going to start by describing a few language features that are important when you're playing around with the Natural Language Toolkit. First one being stop words. Stop words I think are really cool. Basically they're all those words like and, the, a, or, usually very small words. If you had a document and you counted up the numbers of all the words in it, these are the words that would end up being the most common, but other than telling you what language the document is in, they won't tell you much about it. So whenever you're trying to construct some kind of language word frequency thing, you want to go through and take out all of these words first. And so this is how you do it in the Natural Language Toolkit. You have this thing called word tokenize, which is going to appear later. And we have a sentence, and you'll see at the end the words of and these and will have disappeared. Although when you have a stop word list, there's not one absolute list. Every project might need a slightly different list, and I mean, personally, when I ran this, I was assuming that the word some would also disappear because that's a fairly common and not particularly illuminating word. Then we have parts of speech. This is the high school English stuff. So you have nouns, which are just all the words that describe things. So if you're thinking of nouns that were to describe me, I might be a girl, programmer, Python goddess, if that's not too much. Then you have then you have adjectives and adverbs, which are descriptive words. A lot of them end in ly. in a lot of cases, they're words that you can take out of a document and you won't really lose much of the meaning. In fact, it might actually improve it. And finally, you have verbs. And I like verbs because, courtesy of my high school days, I have this little regular expression replacer in my brain. Whenever I see the word verb, it's automatically translated to doing words. So I know those really well. And you'll notice I put these little lettered keys after each of these language features, and these are the things that you'll see come up in the Natural Language Toolkit when you try to tag things for parts of speech. There's a lot more than just these ones. There's loads and loads of them, which is really frustrating, but these are the basic ones that I'm going to play with. And then you have this cool thing called stemming. So back to the whole language frequency analysis thing. Suppose that you have some document and you know that if you explore it, it's going to tell you about different things that people like. And say a whole bunch of people in the document have expressed that they like to fly. The first thing you might think is, well, what have they been smoking? But that's not in what you're trying to discover. So you have this other problem. Some of the people will say, I like to fly. That's all very well. Some other people might say, I like flying. And there'll be one or two people that might say, oh, I flew home last weekend and I really enjoyed it. It's my favourite thing. So when you're pulling out all these words, you might end up with 3 different ways that people are saying they like to fly that should actually be categorised together. And so stemming gets you back to this root word fly so that you can collect all these together. And here's an example of it, but as you will see, it doesn't quite work. Which is great. This is called a feature. But with some words, it will work. So we also have this other thing called lemmatization, which is sort of a synonym for stemming, except that when you do it, you'll actually get a real word. Mind you, it's not actually the same root word, but it's actually a word. So, you know, if you need a word, that's the way to go. So from this, you'll gather that these concepts are really cool, but sometimes the tools that you have available are not going to do what you want them to do or what you expect them to do. So another natural language processing concept is training data. This is a big thing in artificial intelligence. So the idea is that with sufficient previous data, a system can make some guesses about future data that it hasn't yet seen. So it's intelligence through patterns in the data rather than through rules that you've hard-coded yourself. And the Natural Language Toolkit pulls together a whole bunch of different training data sets that have been created by other people. One of these you've already seen, which is the stop words thing. All the stop words sets are corpora, as they're called, or corpus in the singular. Some of the other corpora that are available through the Natural Language Toolkit are one that has a great big list of English language words and also words in other languages. There's also boys' names and girls' names. Some of these may be tagged for parts of speech. Others may be divided up into separate documents, and through the Natural Language Toolkit interface, you can search through these titles and they're used as keywords so that you can subdivide the corpora. Then we have Wordnet, which is more of a dictionary than training data, but I think it's really cool because it's a dictionary that is firstly, as you would expect from a dictionary, readable by humans. So you have dictionary definitions. So here you see one that is for the word animal. But as well as this, it's readable by systems. So if you look at this second example, you get this name, which is animal N01. And one thing that you can tell from that is from the N that this is a noun. There may actually be versions of animal that are not nouns. I haven't actually tested this, but I would imagine that there's another version of animal that's actually a verb. So if you notice, we've collected the definition for the animal at index 0. So if we looked at one, we might get one that's an adjective, not a verb. Pretend like I actually know what I'm talking about, okay? It's a bit of a stretch. Anyway, on to tokenization, which is something that you can do through the built-in Python libraries to a certain extent. It's basically the idea that you have a whole bunch of text and you want to break it up into little smaller bits that make sense for whatever you're trying to do. So here's this being done with just the string split method. So you have your sentence, you run split on it, which means it will automatically split on all the spaces if you don't give it any other parameter. And so now you have a list of all the words. This is how we do the same thing through the Natural Language Toolkit. And isn't it great? You get to import something additional for the privilege of doing this. But you'll notice that the slight difference here is that your question mark also becomes a separate word. This is one of these other wonderful things that you have to check out to see where your punctuation goes. And you can also do things like paragraph tokenization and sentence tokenization, which is shown here. So it's not so obvious on this example, which I made very short so it would fit on the slide, but if you had multiple sentences, they would each be an item in this list. So the final concept I'm going to talk about is wonderfully the spice of life. It's probably pretty obvious from all the previous slides that if you want to come up with a solution to a problem, there's going to be multiple outputs, and you have to look at the output you're getting, understand what's going to happen and how to cover for it. So here's 3 different word tokenizers that are provided through the Natural Language Toolkit. So create an instance of each of them in turn and run it through this sentence, which has a lot of apostrophes in it, just for fun. And as you'll notice, sometimes the apostrophes are with one part of the word, sometimes the apostrophes are with the other. Sometimes the full stop gets to party on with one of the words. Most of the time it gets to be alone. So you just basically need to know how these things are going to work. And again, if you're doing some kind of word frequency analysis, you might find that the most common things in your document are a whole bunch of stop words and a whole bunch of full stops, which isn't going to tell you very much. So, possible applications for the Natural Language Toolkit, because it's really cool, but you might sit there going, well, what do you do with it? The thing that I've sort of been talking about with all these document analysis examples is sentiment analysis or opinion mining, which most importantly enables people to generate more targeted advertisements, because we all love advertisements, right? Other things that you can do are establishing patterns in the language that's used by an individual to make guesses about the person who's talking. This is something that was a big deal when I was doing uni. We'd all go on these sites that would go, we can guess your gender from things you've written, and we'd try to fool them, and frequently we wouldn't, which was a little disturbing. You could also do things like age identification. Maybe people who use the word groovy a lot in their speech are from some other century, and people who, and people who use the word like are pretty much everyone on the planet. There's also something that I haven't really explored, but you can tie the Natural Language Toolkit into, say, Beautiful Soup, which is another really cool Python tool that's out there to do some interesting things with HTML parsing. But the thing that I've bolded, because it's my favourite thing ever, is creating chatbots. So a basic chatbot is something that you can create through a lot of training data and a lot of hard coding. A really good example of a chatbot that's online is the Elyse bot, which has a lot of training data stashed in its little XML files, and presumably a bit of hard coding went into putting all that in the right places. Works really well. You can talk to it forever. Or you can engage in a little bit of clever programming. So how many people here have either played with an Elyse bot or maybe implemented their own? Yeah. Not very much code, is it? And it does something that's freakily cool and makes you want to keep talking. It's pretty interesting stuff. And the other big thing, of course, is how much time do you want to spend on your chatbot? When I was putting together the code for this, it was more how much time do I have to talk about it, which is not very much, so that limited the scope of what I wanted to do. Here's the part where you get to meet my chatbot, although I will say that it's not specifically a chatbot in that it doesn't talk back to people. It kind of is obsessed with a particular topic and will go on about it, and it may or may not notice what you're doing. It's a self-obsessed bot. And so the way this came about was that about a year ago, my boyfriend decided to perform sentiment analysis on my Twitter accounts. He didn't ask permission. I thought that was a bit low, so I've just kind of been waiting for a chance to get back at him. And so now this exists. Isn't it wonderful? Anyone who happens to be sitting on a computer that's internet connected can probably tweet at it and see if it will respond. I'm not sure if it's actually running or if it's exploded, but hopefully it hasn't. It's pretty groovy, isn't it? That picture is a Pokemon. There's two ice creams stuck together. Anyway, so the good thing about chatbots these days is that you can use an existing web interface. You don't have to code your own interface. You can plug all the logic into Twitter. And Twitter does this via this thing called OAuth. So the idea behind this is that you can do things on behalf of an account without having to know their username or password. You do this thing that's really charmingly known as the dance, which is incredibly annoying. The main point of importance here is that last thing, secure equals true. Everything on Twitter has to be done securely now, and if you've missed that out, you'll spend many hours going, why is this not working? Much to your despair. Receiving data from Twitter. Python Twitter tools, which is the Python library I used to do this, lets you just basically plug into the Twitter API, which is pretty cool for now, at least until they make it so that you can only access it half a dozen times on every second full moon. I don't think that's the case yet, but some people have been worried. So here we have receiving data from Twitter. So the easiest way to do it so that you don't keep receiving the same data is to keep track of the last ID you've responded to. In my code, it's automatically set to 1, which will lead to some problems on a second run of the program. But it means that as long as I keep updating which the last ID I've responded to is, I can respond to new tweets without flooding my account. And sending data to Twitter works pretty much how you'd expect. You feed it in some kind of response and it gives it to you. So, how have I evaluated messages that have been sent to this chatbot? Well, the first line here is pretty much what you've already seen. It's a word tokenization of the message, which is the tweet. And then I've done a part of speech tagging exercise on it, which is that second line. One thing that I ended up doing, because it was just too much of a pain to do otherwise, is using this simplify tag thing, which cuts down the amount of tags fairly well so that you're not just sitting there going, what are all these tags even? Because I'm not that good with grammar that I know where every single little thing goes in a sentence. And it can tag in quite great detail, but the simplified tags are pretty good, and from looking at the bot, I've gotten some pretty good results out of it. So here's the sort of things that it does, and from this, if it is actually running, you'll be able to figure out how to make it do horrible things that don't make sense. This is just a small example of all the terrible things it says. So yeah, I load up that document, and then somewhere in my code I have this mapping thing which lets me map each of the things that's in that document, either adjectives, verbs or nouns, to the relevant tags that the Natural Language Toolkit will provide. The one interesting thing is that I put the pro into noun, which is usually where things like the name of the person tweeting or the name of the account go. So every so often the chatbot will acknowledge somebody in a really creepy way. And strangely enough, that's all the slides I have, which hasn't taken as long as I thought, but thank you for paying attention.
Okay, we've got about 10 minutes for questions, and if you can wait for the mic, that'd be good.
I was wondering if you could possibly go back and something you sort of slightly glossed over was sentiment analysis. Mm-hmm. It was an area that's obviously is very useful, one for the targeted advertisements and opinion mining and that sort of thing. Mm-hmm. But it's also something that's very, very hard. You know, you get a sentence like, sarcasm is awesome.
Yes.
And is that a positive or a negative statement? Yeah, well, yes and no. So I was wondering, what does NLTK have, and does it work? Is it any good? Where's the state of the art at the moment with that?
Well, yeah, this is why I put the failure in my subtitle, because you get a whole lot of libraries and great big bits of text and stuff, but really you do need to learn how to write your own documents that will cover what you need to cover. I was doing a little bit of work on sentiment analysis with hashtags a while ago, and I ended up compiling my own stop words list for that purpose, which worked vastly better. I don't think I was using Natural Language Toolkit for that, but it could have been used as a stop words list in there, and it would have been far superior to any of the ones that I was using. So it gives you kind of the framework so that your code will make more sense to you months later, and you know where to plug your text in, but you do really need to know what you're doing, I think. And sarcasm detection, I think, is awesome. It's something I really wanted to do my thesis on, but I thought even I'm not up to that task.
I guess my question is sort of similar. Mm-hmm. Can you put a whole bunch of data into Natural Language Toolkit and ask it to do basic mapping between words like you said, fly, flying, flew, etc., and get it to just spit out statistics, or do you have to manually jigger all that in yourself and then get it to do that?
It does have some statistics type things on it. I think in Wordnet, which I didn't cover too much, there's some tools to let you check the similarity between words depending on what Wordnet thinks. However, I played around with this and looked at some examples on the internet, and I kind of thought the numbers it was giving were rubbish, but there are options where you can get a percentage of similarity between things. And some of the default tools that you get do need to be trained, and when you train them, they can be a bit better, but yeah, you have to exercise your own brain power as well.
Hello? Okay. How good is this for synthesizing languages that have grammar, like German, where you have nominative and accusative and dative and genitive and stuff like that?
I can't say that I've played very much of it with languages other than English. So, yeah, I don't know how competently I could answer that. It does some pretty impressive stuff with not very much. I imagine if you had the right training data, you could get some of these tools to perform quite well.
So, any more questions?
Hey, thanks for the talk. It's really cool to see people doing fun stuff with NLTK. Really quickly with some of the other questions, I think you can find online people doing research and putting blog posts on sentiment analysis and stuff like that. With your chatbot, I actually had a really simple question. Has anyone hooked up another chatbot to interact with it?
No, but it's coming now.
Excellent. Well, I hope something comes during this conference.
Yeah, there's a real shortage of people doing this kind of chatbot stuff on Twitter and services like that. I know there was a project a guy did with his class where he got them to do chatbots and try to get them to interact with real people, but there's not as much of this out there as I thought there would be.
Yeah, I mean, I think, a talk like this, blog posts, stuff like that, where showing people how to actually set it up, I think that's a really great start. Makes it easy.
Is there someone else?
With the tokenizers, I think there was like a whole sentence tokenizer. I was just wondering, is it smart enough to know about the different uses of full stop so that some end a sentence and some just indicate contraction?
I don't know if I've come across an example of that yet. It may well be. So a lot of the tokenizers you can train, and they would probably then be able to recognise that kind of stuff.
Thanks for the talk, really enlightening. Just talking about the identification of people's background or their gender and so on. Do you have to build your own database in order to work that out, or is there open data sets you could compare against? You'd say this person is 65 years old because they talked about looking back Cotter or something.
I don't know if those data sets are out there. It's entirely possible that somebody has them. I don't know if you'd be able to access them freely, but there are a lot of pretty cool data sets out there. Most of the ones that I've looked at, Natural Language Toolkit, are just standard part of speech tagging. But it probably wouldn't be too hard to get a few people to provide some data and get something going there. A lot of the tools that I remember playing with, you would interact with them, they tell you what they think, and you'd say, well, either you're right or you're wrong, and then they would learn from that. So this is probably the way that most people get this data for themselves.
Could you start with a group where you know the characteristics of them, like a specific internet message board, and then mine it for a baseline?
You probably could. That would be an interesting way of doing it.
Thanks.
Okay, if there's no more questions, we'll just leave it there. Considering there's like lunch going on, you can hear all the people eating and you're probably hungry yourself, so... Oh, it's working, yeah. I'd like to thank Elyse for speaking today. That was a very good talk, and I've got some African swallow coffee beans,
Thank you.
which is actually quite a nice fruity blend. And I've also got a Python mug. So
Thanks a lot.
yeah. So let's yeah. Oh, good. I don't have to ask for a round of applause. You already gave one. Okay. Anyway, if you want to go and have lunch.